SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, water plumes discovered on Jupiter's ice moon Europa. SpaceX says 1 million people could be living on Mars in 40 years. And initial reports on the Falcon 9 rocket disaster. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers using NASA's Hubble Space Telescope have imaged what appear to be water vapour plumes or geysers erupting from the surface of Jupiter's ice moon Europa. The new findings, reported in the Astrophysical Journal, supports previous Hubble observations suggesting the icy moon erupts with high-altitude water vapour plumes. The observations increase the possibility that missions to Europa may be able to sample the moon's global subsurface liquid water ocean without having to drill through kilometres of ice. Europa's ocean is considered one of the most promising places in the solar system that could potentially harbour life. The plumes are estimated to rise to about 200 kilometres before presumably raining material back down onto Europa's surface. Europa's massive global ocean contains twice as much water as Earth's oceans, but is protected from space by a layer of extremely cold hard ice of unknown thickness. The plumes offer a tantalising opportunity to gather samples originating from under the surface without having to land or drill through the ice. The research team who made the discovery, led by William Sparks from the Space Telescope Science Institute in Baltimore, Maryland, observed a series of finger-like projections while viewing Europa's limb, that is the edge of the moon, as it passed in front of Jupiter. The original goal of the team's observing proposal was to determine whether Europa has a thin extended atmosphere or exosphere. Using the same observing method that detects atmospheres around exoplanets orbiting other stars, the team realised that if there was water vapour venting from Europa's surface, this observation would be an excellent way of seeing it. The atmosphere of an extrasolar planet blocks some of the starlight that's behind it. And if there's a thin atmosphere or exosphere around Europa, it too has the potential to block some of the light coming from Jupiter, and Sparks and colleagues would see it as a silhouette. So the authors began looking for absorption features around the rim of Europa as it transited the smooth face of Jupiter. The team observed Europa passing in front of Jupiter in 10 separate observations spanning 15 months. They saw what looked like plumes erupting on 3 separate occasions. The new findings support earlier observations in 2012 by a team led by Lorenz Roth from the Southwest Research Institute in San Antonio, Texas, which also detected evidence of water vapour plumes erupting from the frigid south polar regions of Europa and reaching more than 160 kilometres into space. Although both teams used the Hubble Space Telescope imaging spectrograph, each used a different independent method to arrive at the same conclusion. Sparks says his calculations of the amount of material that would be needed to create the absorption features his team saw was similar to what Roth and his team found. Although both teams used different methods, the estimates for the mass were similar and the estimates for the height of the plumes are also similar. However, so far, the two teams haven't simultaneously detected the plumes using their independent techniques. The observations so far suggest the plumes could be highly variable, meaning they may sporadically erupt from time to time and then die down. For example, observations by Roth's team within a week of one of the detections of Sparks' team failed to notice the plumes. Still, if confirmed, Europa would be only the second moon in our solar system known to have water vapour plumes. Back in 2005, NASA's Cassini spacecraft, which is studying the Saturnian system, detected jets of water vapour and dust spewing out of the South Pole tiger stripes on the Saturnian moon Enceladus. As for confirming the venting or plume activity on Europa, scientists could use the infrared vision of NASA's new James Webb Space Telescope to do that. The James Webb is slated for launch on an Ariane 5 rocket from the Kourou Space Centre in French Guiana in 2018. NASA's also formulating its own mission to Europa, with a payload that could confirm the presence of the plumes and then study them from close range during multiple flybys. SpaceX and Tesla boss Elon Musk has finally announced his long-term plans for missions to Mars. The PayPal entrepreneur has unveiled plans for a fleet of massive reusable spacecraft, each capable of carrying between 100 and 250 people and 450 tons of supplies to begin the process of colonising the Red Planet. Musk has told the International Astronautical Congress in Guadalajara, Mexico, he plans to send the spacecraft in armadas during the regular 26-month launch window cycle between Earth and Mars, when travel times would be at their shortest duration. The new interplanetary spacecraft will be launched into Earth orbit on a new super heavy lift booster, far bigger and more powerful than even the mighty Saturn V Apollo moon rocket. And unlike SpaceX's existing Falcon 9, which uses 9 RP-1 kerosene propellant rocket motors, the new super heavy lift booster will use no less than 42 of SpaceX's new Raptor methane rocket engines on its main stage booster. After placing the interplanetary spacecraft into Earth orbit, the reusable launch vehicle would then return to the launch pad using a supersonic retropropulsion system. SpaceX already uses the same technique to return and soft land spent Falcon 9 core stages back on Earth following each launch. Once on the ground, the launch vehicle would be serviced and refueled, and a propellant tanker carrying fuel for the journey to Mars would be attached. The heavy lift launcher would then blast off again, carrying the propellant tanker to rendezvous with and fuel the interplanetary spacecraft in Earth orbit before the spacecraft begins its long journey to Mars. The interplanetary spacecraft would travel to Mars cruising at about 100,800 kilometres per hour. However, Musk says the journey time could be slashed to as little as 80 days if the spacecraft is accelerated to even higher speeds. Once it arrives at Mars, the interplanetary spacecraft would use the supersonic retropropulsion system to land on the red planet's surface. After the passengers and cargo are offloaded, the interplanetary spacecraft would be refueled for the return journey to Earth using methane produced out of the Martian carbon dioxide atmosphere or from subsurface Martian water. Musk says his new interplanetary spacecraft could be flying by 2024. He claims launch costs could be as little as $140,000 per ton of cargo, with passenger tickets to Mars costing as little as $100,000 per seat. If Musk's vision for the future does come to fruition, he thinks there could be 1 million people living on the red planet within 40 to 100 years. The project will begin with the launch of the first SpaceX Red Dragon missions to Mars in 2018. Red Dragon will use SpaceX's new Dragon V2 capsule, which is designed to transport crews to the International Space Station. However, the Red Dragon will be unmanned for its flights to the Martian surface. Instead of carrying crew, it'll carry scientific payloads, including equipment to test critical technologies needed to land massive payloads on the surface of the red planet. Red Dragon will launch on SpaceX's new Falcon Heavy rocket, which is slated to undertake its maiden flight next year. While the first Red Dragon mission is likely to be more of a technology demonstrator than anything else, follow-up missions roughly every 26 months will carry a range of scientific payloads for both SpaceX and for NASA. And Musk's vision isn't just limited to Mars. He says the same launch system could be used just as easily to explore the rest of the solar system as well.
So then what about beyond Mars? So as we thought about the system, the reason we call it a system, because generally I don't like calling things systems because everything's a system, including your dog, is that it's actually more than a vehicle. There's obviously the rocket booster, the spaceship, the tanker, and the propellant plant, the in situ propellant production. If you have all of those four elements, you can actually go anywhere in the solar system by planet hopping or moon hopping. So by establishing a propellant depot in the asteroid belt or on one of the moons of Jupiter, you can make flights from Mars to Jupiter no problem. In fact, even without a propellant depot at Mars, you can do a flyby of Jupiter without a propellant depot. So, but by establishing a propellant depot, let's say Enceladus or Europa or any of this few options, and then doing another one on Titan, Saturn's moon, and then perhaps another one further out on Pluto or elsewhere in the solar system. But this system really gives you freedom to go anywhere you want in the greater solar system. So you can actually travel out to the Kuiper Belt, to the Oort cloud. I wouldn't recommend this for interstellar journeys, but this basic system, provided we have filling stations along the way, means full access to the entire greater solar system.
The Australian state of Queensland was rocked by what appears to have been an air-bursting meteor on Monday evening. Local residents in central and southern Queensland reported seeing a bright flash of light followed by a loud explosion at about 8:30 local time. People described the fireball as bright as a mini sun lighting up the skies, with a big orange tail suddenly appearing. Sightings of the event were reported across a wide area of the state, from Emerald in the west through to Hervey Bay in Yeppoon north of Gladstone. In fact, there were hundreds of sightings, including reports of a tremor from the Gladstone area itself, which is located about 400 kilometres north of Brisbane. There were also reports further south on the Sunshine Coast hinterland of a second similar light seen streaking across the skies about 2 o'clock the following morning. That indicates a possible second meteor event, although the Earth's rotation and orbital travel indicate that the two events probably aren't linked. Most eyewitnesses reported the light was coming straight towards them, effectively ruling out space junk, which would have entered the Earth's atmosphere at a far shallower angle. Interestingly, Geosciences Australia did detect a 3.8 magnitude earthquake off central Queensland's Airlie Beach in the Whitsundays about 2 hours later. Earth is hit by around 100 tonnes of space rocks and dust every day. Most of this material burns up unnoticed in the upper atmosphere. As they travel through the atmosphere, they can reach temperatures of up to 10,000 degrees. However, larger ones can reach thicker layers of the atmosphere, where they light up as meteors, putting on a spectacular show. Depending on their size and composition, these will usually either burn up as fireballs in the atmosphere, or for some, if they're big enough, the heat of entry will cause them to build up internal pressure and eventually explode as an airburst, sending shock waves often associated with a deep rumble or a sound like thunder. The explosion happens either through air pressure or because meteoroids can be very cold, often having travelled for billions of years through space. However, as they enter Earth's atmosphere and suddenly heat up, they get searingly hot on the outside while still retaining their cold interiors, which often contain tiny voids or air pockets full of gas. These pockets can suddenly heat up, expand and explode. It's only the larger meteors which survive their journey through Earth's atmosphere which make it to the ground as meteorites. Okay, time for a bit of terminology right now. Bits that break off asteroids and comets in space are referred to as meteoroids. When they light up as they enter the atmosphere, they're called meteors. Those brighter than the planet Venus, the third brightest object in the sky after the Sun and the Moon, are called fireballs. And fireballs that explode in the air are called bolides. Once a meteor reaches the ground, it's called a meteorite. By the way, meteor showers, which are sometimes wrongly referred to as shooting stars, see they're not really stars, are events that occur at the same time each year as Earth's orbit takes it through the debris trail usually left by a comet. One of the world's largest radio telescopes has formally opened in China. The 500-metre Aperture Spherical Telescope, or FAST, nicknamed Tianyan, or Heavenly Eye, is a half-kilometre wide dish located in a natural depression in southwestern China's Guizhou province. The only larger radio telescope is the Rattan 600, a 576-metre diameter circle of rectangular radio reflectors and secondary reflectors and receivers located in Russia. FAST is one of the most sensitive radio telescopes ever built, and the huge amounts of data produced will allow astronomers to map hydrogen gas in the Milky Way, hunt for rotating neutron stars known as pulsars, and look for signals from extraterrestrial intelligence. FAST uses a fixed primary reflector, focusing radio waves on a receiver suspended 140 metres above it. The reflector uses perforated aluminium panels, supported by a mesh of steel cables hanging from the rim. FAST's surface is made up of some 4,450 triangular 11-metre panels forming a geodesic dome. 2,225 winches located underneath make it an active surface, pulling on joints between panels, deforming the flexible steel cable support to a parabolic antenna aligned with the desired direction in the sky. Although the overall reflector diameter is 500 metres, in reality only a circle of about 300 metres in diameter can be used. The basic design of FAST is similar to the 400-metre Arecibo Observatory radio telescope in Puerto Rico. Both are fixed primary reflectors installed in natural hollows. However, Arecibo's dish and platform are both fixed in place, while the FAST dish is significantly deeper, contributing to a wider field of view. Arecibo's larger secondary platform also houses several transmitters, making it one of only 2 instruments in the world capable of radar astronomy. The Arecibo Observatory also has the advantage of a location closer to the equator, so the Earth's rotation scans a larger fraction of the sky. FAST uses a 19-beam receiver built by Australia's CSIRO as part of a collaboration between the Australian Academy of Sciences and the Chinese government. It also uses a data transmission system developed by the International Centre for Radio Astronomy in Perth to manage the huge amounts of information it generates. The software, called Next Generation Archive System or NGAS, helps astronomers using the telescope collect huge amounts of data. One of the system's developers, Professor Andreas Wissenek from the University of Western Australia, says the NGAS data system will help collect, transport and store about 3 petabytes of information a year from the telescope. Well, getting that kind of capacity isn't too hard anymore. The main challenge is transporting that amount of data and having the network bandwidth to move it around. The FAST telescope is acting as a technology pathfinder for what will be the world's largest telescope, the multi-billion-dollar square kilometre array now being built in Western Australia and South Africa. Professor Wissenek says the NGAS data system is already being used on the European Southern Observatory, in the United States on the National Radio Astronomy Observatory, and on the Murchison Wide Field Array in outback Western Australia.
The system had been developed back in 2000 already for the European Southern Observatory and actually deployed in the Atacama Desert in Chile on several telescopes. And since then we've used it all around the world. We have optimized it quite a bit for much bigger data flows than what ESO usually has. So that's the background of the whole story, and we are using it now for a lot of radio telescopes as well.
And one of those, of course, is FAST. This is a massive telescope, a half-kilometre wide dish.
Yeah, so it's quite amazing, this piece of engineering over in China. We went there in May, and it's quite stunning just seeing it, and this huge structure, and it's all steerable in principle. Well, steerable not fully, but at least the panels are steerable, and that's a quite amazing piece of engineering, for sure. In a way, of course, now it has been also elected to be a pathfinder for the square kilometre array, mostly for technologies and data transfer and stuff like that.
What sort of work will this be looking at compared to the type of astronomy that the SKA will be doing?
Yeah, it's actually quite interesting. One of the main goals of the FAST telescope are pulsars, and that's also one of the main goals of the SKA. Now, for pulsar research, you actually don't need a lot of resolution. You just need to know where those things are and then measure them in a very, very precise manner, and that means time-wise precise. And FAST is perfectly suited to do that. You don't want to resolve that object, you just want to see the pulses, and that's perfect.
We've been looking at pulsars for a long time now. These are rotating neutron stars. What makes them so interesting?
Well, there are several things. Of course, the physics involved in those objects is quite extreme, so just for that reason it's already interesting, because it's very extreme physics. And
yeah, you can't get any denser unless you go for a black hole.
Exactly, and then that's of course kind of a laboratory for those very extreme physics. But then on the other side, you can also use them for all kinds of other things, including finding gravitational waves, and that was the original intent for getting a lot of pulsars measured, and use the best ones, actually the most precise ones in terms of the pulses, to get a hint on gravitational waves as well. So you would use the pulses and the difference in arrival times of the pulses across the sky to see gravitational waves from other objects, and that's actually quite an interesting way of using pulsars.
Sort of like an interferometer.
Yeah, it's pretty much like that, yeah.
Oh, wow.
But in gravitational waves.
Tell me a little bit about the NGAS data system.
The system is really just a data management, data flow control system. So it's concentrating exactly on that. And what we called it in the beginning was a globally distributed file system. And globally distributed means really around the world because we've used it in that way. So data is captured on very remote observatory sites and then going to some more central sites or sites where people can actually use the data and do reduction of the data. And at the time in 2000, there was nothing comparable around at all to do that on, first of all, network, but actually in that case, we did it through disks. So we actually sent disks around every 2 or 3 days on a courier service and got them for many years, got them into Munich area and used them there in big archives. So that was a fairly unique feature, fairly unique still. That's why we are still using it.
That's got to be cumbersome. It must be much better if you could sort of transfer the entire data pool, whatever it is, on some sort of a really large bandwidth network.
Absolutely. If you have that network, if you have the luxury of that network, it's great. And that's why the system in the meantime, of course, supports even mixed or pure network transfers. So mixed means we can do partly in disks and partly on network, and it's still all tracked and we know where the data is at any given point in time. But then if you compare actually the bandwidth you could get through shipping a whole container of disks around is much, much bigger than any network you can have. The latency is horrible, but the bandwidth is incredible.
This is all working towards, of course, developing the square kilometre array both in Western Australia and also in South Africa.
Yeah, so it's part of our prototyping. And I mean, the system in this case, the NGAS system in this case, of course, we're using in operations, which is perfectly fine. And I'm not sure whether that system would really scale to the SKA scale, but we are gaining so much experience and expertise in using that system and scaling it up to the next stage, like SKA or other systems as well, like the FAST system or other telescopes right now as well. So we are gaining a lot of experience in doing that. And then picking the right solution for the SKA is probably much easier in doing it like that.
As well as the FAST telescope, it's also being used by the National Radio Astronomy Observatory. Is that the one at Green Bank in West Virginia?
Yeah, so they have several ones. Green Bank is one of them, but the bigger one is the very large array in New Mexico, close to Socorro.
Made famous in the movie Contact.
Yeah, exactly, that one. So, and it's used internally in ASCAP as well, not for the main data transport, but internally in the POSI supercomputing center. So we have it installed there as well.
That's Professor Andreas Wissenek from the University of Western Australia and the International Centre for Radio Astronomy. A breach in the upper stage helium pressurization systems being blamed for the explosion which destroyed a Falcon 9 rocket at the Cape Canaveral Air Force Base in Florida in early September. The preliminary findings have come from an initial investigation looking into the disaster, which occurred during fueling for a static test fire of the launch vehicle. The dramatic explosion destroyed the Falcon 9 as well as its $200 million satellite payload and the surrounding infrastructure at Space Launch Complex 40. The Joint Accident Investigation Team, comprising people from SpaceX, the FAA and the US Air Force, say data loss caused by the blast occurred just 93 milliseconds after the initial signs of an anomaly. The team is still sifting through some 3,000 channels of data and examining debris collected from the site, which has been taken to a hangar for storage. The Accident Investigation Team say a large breach appears to have occurred in the cryogenic helium pressurization system of the launch's upper stage liquid oxygen tank. The tank contains several composite helium vessels designed to pressurize the propellant tanks to maintain structural integrity as the engine uses up the tank's fuel supplies. The Falcon 9 was slated to launch 2 days after the test, carrying Facebook's Amos 6 telecommunications satellite owned by Israel Spacecom. SpaceX says it doesn't know how long it will be before flights can resume at Cape Canaveral Space Launch Complex 40, which was extensively damaged in the blast. However, while the strongback, lighting towers and adjacent support facilities were destroyed, the vehicle assembly building, the payload processing facility, the Falcon 9 support structure, as well as launch control center, liquid oxygen farm and RP-1 kerosene propellant fueling system have all survived virtually intact. SpaceX are yet to announce when Falcon 9 flights will resume. As well as Cape Canaveral Space Launch Complex 40, SpaceX also flies from Space Launch Complex 4 East at the Vandenberg Air Force Base in California. And it's currently constructing a new launch pad on the old Apollo Saturn V moon rocket and Space Shuttle Launch Complex 39A at Cape Canaveral's Kennedy Space Center, which they're leasing from NASA. Both 4 East at Vandenberg and 39A at Cape Canaveral are being designed to take both the Falcon 9 and Falcon Heavy launch systems. Back in June 2015, another Falcon 9 blew up just 2 minutes into its flight while carrying the Dragon CRS-7 cargo ship bound for the International Space Station. That failure was eventually traced to a faulty strut supporting a pressurized helium vessel inside the upper stage liquid oxygen tank, which fractured under the high G's of acceleration during launch. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine. This month, looking at whether the next generation of supercomputers will be able to handle the mega streams of data expected from the next generation of giant telescopes like the Square Kilometre Array.